Welcome to this new video focused on the linear dependence and independence. So basically, we used to have a set of vector or a given set, and the question is, can we prove whether the set is linearly dependent or not? So the essence of this video is to answer such question. Okay, so every set you have, you should be able at the end of this video to say whether it is linearly dependent or not. All right, let's start with the definition. What is the linear dependent set? Definition: a set of vectors S is equal V1, V2 to Vn is linearly independent only if the solution to this alpha, if you have alpha V1 plus, let's say alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3 plus up to alpha n Vn is equal 0. So the solution to this is alpha 1 equal alpha 2 equal alpha 3 equal alpha n and equal 0. Okay, so if this is the definition, if one of these alpha is not 0, then we can conclude that it is linearly dependent. In that case, we will say that the set is linearly dependent. This is the definition. Okay, so if any set of vector will have this trivial solution, then we will say that the system is linearly independent. Okay, so let's take some example and see. First example, you are giving the following set. We let S is 1 0 0 plus 0 2 0 plus 5 4 0. The question is the following: is this set linearly dependent or independent? So based on what we obtained here, we have here from the definition, we should be able to answer this question. Okay, how do we do that? If we call this one, the first vector is V1, this is V2, and here is V3, we have by definition alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3 should be 0. Okay, now let's substitute V1, V2, and V3. This is alpha 1 times 1 0 0 plus alpha 2 0 2 0 plus alpha 3 5 4 0. This is equal 0. All right, at this stage, we can choose different value of alpha 1, alpha 2, and alpha 3 such that we still have 0 here. If I give the value 1, if you check the first entry of each vector, we have 1, 0, and 5. Okay, so it means that if alpha 1 is minus 5, and for the second one, if alpha 1 is minus 2, and here is 1, then we have 0. So if we obtain something like this, alpha 1 is minus 5, alpha 2 is minus 2, and alpha 3 is just 1. Then in this case, you see that if you multiply, you see that you obtain 0, right? For the first row, first entry of the vector, second entry, and third entry, you obtain 0. So in this case, alpha 1 is different from 0, alpha 2 different, and alpha 3. And the conclusion is simple. It's not 0 as the definition says. Therefore, the conclusion is simple. The system is linearly dependent. Okay? Let's look at the second example. All right, for this second example, if we call this V1, V2, and V3. Then, by using the definition, we have alpha V1, alpha 1 V1, plus alpha 2 V2, alpha 3 V3 is equal 0. We know alpha 1, alpha 2, alpha 1, 1, 2, 3, plus alpha 2, 4, 1, 5, plus alpha 3, 2, 3, minus 1 is equal 0. This is a 0 vector. All right, this system is equivalent to the following augmented matrix. We have first column is 1, 2, 3, 4, 1, 5, 2, 3, and minus 1. 0, 0, 0. All right, we have this matrix, and I want us to do some Gauss reduction. Okay, remember from the previous videos, you know how to do the Gauss reduction. We have to do some Gauss reduction here to eliminate these 3 entries of this matrix. If the second row become, if R2 become R2 minus 2R1, then we have 1, 4, 2, 0. This is minus 7, and the last one is minus 1. For the third row, if you take this, R3 become R3 minus 3 R1, then we have 0, 5 minus 12 minus 7, minus 7. All right, we have to eliminate this last entry, and this is simple. We can just use the second row, third row minus second row. Then we have the first row is the same, second is the same, and the last one will be 0, 0, 6. All right, at this stage, we can conclude that the only solution to this system, given that this system have exactly one solution, if you remember, when the system have one solution, many solution, and no solution, those are the 3 options when you do the Gauss reduction here, right? So in this case, this is the case where the system only have one solution. It clearly means that the system is linearly independent. So the only option here is alpha 1 equal alpha 2 equal alpha 3, and it's equal 0. All right, as I say, when you reduce the matrix and you obtain one solution, when the matrix have exactly one solution, in that case, we say that the system is linearly independent. When the system has many solutions, we say the set is linearly dependent, okay? All right, let me give you this last example, very short one. Let's consider example 3. Let's consider this set. Let S be a set of vector x squared, x, and 1. We want to show that this set is whether it's linearly dependent or not. Okay? So in this case, we use the definition alpha x squared plus beta. Of course, if I use alpha 1, alpha 2, alpha 3, and we use alpha, beta, gamma, it's still the same, right? So alpha x squared plus beta x plus 1 is equal to 0. Is this possible? Let's see. If x is equal 1, then this system becomes alpha plus beta plus gamma is equal 0. Okay, we do the same when x is minus 1, then we have alpha minus beta plus gamma is equal 0. And let's take the case of x equal 0. In this case, you have 0 plus 0 plus gamma is equal 0. From the third equation here, we solve for gamma. Gamma is 0. We substitute here 0, 0, and we solve for alpha and beta. We find that alpha is equal beta is equal gamma and 0. And therefore, we conclude that this set is linearly independent. Okay? So as your own example, I want you to do this. Show that example 4 is the following set linearly dependent or not. So I want you to look at this. This set S is 1, 2, 3, 4, 1, 5, and the last vector is 2, 3, and 5. All right, as assignment, I want you to solve this system, okay? Tell me whether this set is linearly dependent or not. Basically, you just have to use this same procedure. So you use the augmented matrix form and Gauss reduction, and you'll be able to say whether it is linearly dependent or not. So this is all for this video. Thank you.